You can see from here, she is a professor of University of Grenoble as well as director of CNRS Research Direct. You can Google her name. If you submitted papers in last BLDB, you know who she is. Okay? I don't need to tell you a lot about her. She's very well known in her field. So let me tell you something you cannot Google, or you cannot find by Googling about her. So she's a great program chair. So if you are going to organize conference, you need a program chair.
I am
She's
done.
standing right, she's writing up there.
Maybe a lot of money. I am done.
Because I have worked with her for more than a year for BLDB, she is very efficient, very responsive, and she didn't tell me to tell all this, okay, so just to make sure. So I will open the floor for Sihem.
Thank you, Suraj, and hi everybody again. Yeah, well, thank you for inviting me because I'm really excited to be here, and I've never been to Hong Kong before, so I'm here until tomorrow evening, flying back tomorrow. I'm going to tell you about some of the work that we started quite recently. In fact, it's work that I'm doing with Shadi Bassouni, who is at the American University in Beirut, in Lebanon, and a few students, and we presented this last week at EDBT. And we also have a tool, if you're interested, we're packaging it, putting it on GitHub. All right, so this is the story. The context of the work is online labor markets. It does apply to a number of other contexts, but I'm going to focus on this for the purpose of this talk. And what are these marketplaces? They're basically serve as intermediaries to connect people who are looking for a job and individuals or others who have something to propose to get done. And there's a number of platforms, and the main difference between these platforms is that some of them are fully virtual, right? So for instance, you want to hire somebody to design a logo for you, right? Or a website, right? So you don't need that person to come physically to your place or to meet you somewhere. Or you may want to hire someone to move furniture, or to do whatever else requires a person to be at a particular location. That's the case, for instance, for TaskRabbit, which has a mix of virtual physical work, and then a number of others that are all over the world. And one other thing that really is appealing about these platforms is that, supposedly, as a worker, you can find any kind of job you're looking for, and for any duration. And of course, what's appealing is that it's really sort of very flexible in the sense that, you may have 2 hours, and you say, why not? I'm going to work on a resume for somebody and get paid. Okay? So this is how it works. Just to give you one example, this is a platform that's in France. It's called Kappa. And so at the top there, you can see there are keywords. So this is your query, and generally a query is a mix of keywords and location, when location is necessary. And then you get a ranked list of individuals, right? You can see a number of things about these people. What was the last job they got? Where do they live? And sometimes additional information about their profile. Okay? So definitely there is a decision that's made by an algorithm that's going to rank these people based on the query or based on their qualification. There is a number of other things, criteria you may be using, which is mainly like experience level, distance from some location, and so on. Okay? Now, one can see it like this, right? So each line is an individual, and the main thing is that there is a task, which is a query, that is a mix of keywords and possibly location, and a set of workers, and the workers are ranked according to their qualification computed by the system. So, for instance, the qualification could be something like, language test and approval rate in the system. That's a computed attribute, right? So a number of such scoring functions, in a way, may be used. They are, job dependent and requester dependent, and so on, right? So no harm a priori in this. Obviously, you do need to compute some qualification for the job that is then used to rank people according to for a given query and potentially a location. Okay? So now let's keep in mind that these people may have a certain number of attributes that we're going to refer to as protected attributes in terms of the law, and a number of other attributes that may be inferred or computed based on the work that you have done on the platform. Okay? So now what's my message here is that I'm interested in trying to quantify discrimination or understand how even to start thinking about this problem, right? So what does it mean to discriminate? In its general terms, the discrimination is defined as the unbalanced targeting of workers based on their protected attributes, right? So even though your scoring function is not necessarily expressed on such protected attributes, right, like what we've seen just before, you may actually end up potentially discriminating between different groups of people that are identified by a combination of such attributes, okay? For instance, in a number of criminal laws in the world, including US, also French criminal law, have a number of such attributes that are protected, right? Your health status, your gender, your location, and a number of other things, ethnicity, your sexual orientation, I mean, a number of other things about yourself. Obviously, it should be sort of based on individual attributes, but also combination of such attributes, right? We understand that as computer scientists, lawyers don't necessarily understand the notion of combination. So I'll come back to this. All right, so in the literature, fairness is actually a hot topic, and a lot of people are working on it. And in particular, it's been studied quite a bit for classification and for ranking, okay? And binary classification mostly. And one can have find many definitions of this notion of group fairness as opposed to individual fairness. And group fairness could be, for instance, demographic parity, right? You want the same proportion of males and females, right, to appear in your result. Or you want, generally a lot of these fairness definitions are not necessarily possible, but one could have such definitions. There are also things about the disparate treatment and disparate impact that have been studied mainly for web search and for exposure, right? So whether you're exposed or not in the top K results, okay? But one observation about existing work is that people actually looked so far at single attribute groups, right? So the question that's asked is a hypothesis. Are people discriminated based on ethnicity? Are they discriminated based on gender, okay? And mostly, empirically, for instance, this piece of work, I encourage you to read it, Bias in Online Freelance Marketplaces, they're asking themselves the question of, are people discriminated on TaskRabbit? Are they discriminated based on ethnicity? And they look at empirical results. Are they discriminated in their ranking based on gender? All right? So we want to take it to the next level of algorithmically. Okay, so one possible statement is the following. What you want is to, given a set of workers and a scoring function, right? It's associated to a query or to a requester or to a number of queries. What you want to do is to find subgroups that for which you can compute the notion of discrimination or unfairness, and you want to find those subgroups that exhibit the highest unfairness. Of course, you can have many problem statements. This is one possible problem statement, and quantify that amount of unfairness in the ranking. Okay? So here we are. So this is one way of formulating the problem, which is simply taking the set of workers and partitioning them, creating a total partitioning of those workers, right? And studying all possible partitionings, right? P1 through PK. This is one possible partitioning. And in this case, I'm just defining, formalizing that as an optimization problem where I'm trying to find the partitioning that exhibits the highest unfairness, for which I compute the highest unfairness, okay? So how do I compute that? I'm going to look simply at the score distributions within the groups and compute distances in those score distributions between the groups, and I take the average of pairwise distances, and I'm going to select the partitioning that is going to have the highest such value. Okay? So here, for instance, I take two partitions inside this partitioning. I'm computing their histograms, which are the score distributions assigned by the scoring function. I'm computing EMD, which is one way, it's Earth mover's distance, which is one way of comparing distributions, score distributions. I'm computing the average over the full partition, and then this is what I'm using as my formula. All right? So here's how the space looks like. You don't need to think of it as a tree. You can think of it just as a number of partitionings. At each level here, I have a full partitioning. Okay? So here I have the full data set with a given score distribution. Then I have, males and females, and that forms the full partitioning with the score distributions assigned to these. Okay? So if I compare these two distributions based on EMD or any other distance function, then I can quantify based on gender, right, the amount of the difference between the people here and the people here with respect to the scoring function. But in this general form, I could be comparing, for instance, this partitioning, right? So these ones and this one based on ethnicity and gender. All right? So this is sort of just the general space. Now, if you see it as a tree, then you can start using all sorts of nice algorithms for partition decision trees, for instance, and then stopping conditions such as, I could, or gain functions, for choosing your partitioning attribute based on discrimination or unfairness. Okay, so that's really the core of it. Let me give you some results that we have on analyzing TaskRabbit data. So this is one analysis where we went and got the 20 most popular services or queries on TaskRabbit in 45 US cities. And for these ones, we counted a little over 2,000 unique workers, 287 queries. An example query is home cleaning in New York City, for instance. And what we could get, what you can basically just scrape from the website, is the rank of each tasker, the picture, a badge, reviews, and hourly rate. Okay? So you don't need to know how the algorithm functions. What you know is simply that for a given query, you get a certain ranking of the top 50 workers among all the workers that are available. Okay? Then, of course, what we wanted is to figure out what the gender and ethnicity of those individuals were. We wanted to know more, but these are easy to get. We crowdsourced the pictures of those people. And based on those pictures, we had people simply assign a gender or an ethnicity based on the picture. Okay? This is simply just to show you the distribution of our crowd force. There's a certain number of males and females, and the ethnicity, we had people just look at these major ethnicities: white, black, and Asian. Okay? So this is for the 2,000 taskers. So what I'm going to look is simply use the algorithm for my queries and see, what kind of results I'm getting. So for instance, one thing that you could observe, with the algorithm is that for 112 queries, like for, say, the majority of queries, ethnicity, the highest unfairness or highest discrimination was observed based on ethnicity. Okay? So the algorithm just split on ethnicity and stopped. For about 89 queries, the algorithm split on gender and stopped. This is where it found the highest, the partitioning that exhibited the highest fairness, as defined by our algorithm. And then for the rest of queries, it was based on both, right? Ethnicity and gender was what we could see. So for instance, out of the 112 queries that we have, so the previous ones, which are the ones that are based on ethnicity, the 3 ethnic groups, what could we see? One thing we could see is that, so all 112 queries returned, white taskers in their top 50 rankings, and that's more or less consistent with the underlying distribution. Okay? This is an important point because our goal is to quantify, not necessarily to explain or interpret, or at least we can attempt to interpret things. But of course, one of the reactions could be, immediate reactions, could be that, yes, of course, you have more white people in some areas because there are more white people who are available, right? Or more women because there are more women, and so on, right? But this is simply to tell you that that's the case for instance, in this case, it is actually consistent with the underlying distributions. But here, for the other queries, the 89 queries, for instance, that we could, for which gender seemed to be the highest sort of discriminating attribute, for those queries, the 83% of the top 50 in those queries were males. And that's not consistent with the underlying distribution. In the underlying distribution, there are more women than the ones that are selected in the queries. Okay? So that's one result. I mean, then you can start slicing and dicing any way you want all these results. Okay? So one, for instance, is that out of 77 queries which split on ethnicity and gender, this was the last number. White females were in the top 50, as opposed to, for instance, only 61 black females, and Asian females were even, much fewer, right? 19 of them. In fact, there are much fewer Asian males who appear in the top 50 of the queries that discriminate mostly on ethnicity and gender than on any other queries. Okay?
In Sihem, you're looking very specific job, right? Not close.
Each query is a job. So I have 287 jobs.
Of these.
Absolutely. That's right. So for instance, this is another way of looking at how you slice the problem. So this is the EM, the average EMD that we are computing, meaning the amount of discrimination.
So
right?
handyman, the population itself is biased.
Absolutely, yes, of course. But even if you bring it down to the distribution that you have, right, in the individual cities, that you still can observe this skew. Okay, so this is simply showing the skew, and the highest discrimination is for queries on moving, and then the lowest is for event staffing. Okay, so this is a quantification, right? It's saying here is what I'm seeing. You can also break it by location, so the highest discrimination, overall the average, the average is in San Antonio, Texas, and the lowest is in Phoenix, Arizona, okay? And then you can do it also per type of job and so on, right? So that's where we are, okay? So basically, I don't have a particular explanation. I'll tell you, one possible explanation is that ranking is not just based on qualification, it's also based on feedback. Okay? And there is one piece of work that simply empirically showed that, when you're showing your picture, which is in most cases here, feedback is negatively correlated with certain ethnicities or certain gender. Okay? So of course, we're talking about a black box here, right? Because we're looking just at the ranks of individuals from the query. So anyway, so what I wanted to spend a little bit of time on this, and I'm hoping I still have some time, right? Okay, good. So basically, really what we were after is more like a framework, right? So we said, how can we quantify this notion of discrimination and reason about it algorithmically? Because most of the work is very much empirical, asking a hypothesis question and then going about it, or very theoretical, right? If I assume a certain number, basically about decidability, right? Because in ML, a lot of people have asked themselves the question of, if you define discrimination this way, can you actually find the solution, or can you quantify it, right? So really what we were after is to think of the problem as a partitioning problem. It really is about looking at any possible subgrouping or partitioning, and defining these distances in the way positions are assigned or actual scoring values are assigned. So if you, in the TaskRabbit experiment, it really is about just your position in the rank. I have no idea what your scoring is, so it's about exposure. So for instance, we used this Earth mover's distance to compare the score assignment or rank assignment across multiple groups. But you could explore different ways of comparing, right? We're just plugging this way of comparing different partitionings. Also, the optimization problem itself could be formulated in many ways. For instance, what I've shown you is sort of this global view on a set of queries, a population of workers, and here is what I can observe, or a set of such queries. I could do it per location, right? I could do it also from the viewpoint of a worker. What would a worker want to see? A worker may say, this is my profile. This is what I belong to. Now I have a choice in a given location between a number of queries. Which query do I have, for which kind of queries, which subset of queries am I most likely going to get the job? Right? So nothing, no changes to the underlying, algorithm or ranking mechanism. Simply, as a worker, you could use this, right? And then you could use it, of course, as an auditor, right? So now the European Commission is asking itself a lot of questions about how to train auditors to go and audit systems, right? About transparency and all sorts of other things, right? But as an auditor, you could use it without even having the internals, knowing the internals of the system, as long as your problem is a problem of ranking for a given request, right? And finally, you can use it as a job owner, somebody who wants to post a job, right? And reach out to a certain population, for instance, somewhere, right? So you can, look at it as the problem of how to define the right scoring function. Okay? So this is basically what I mean by the optimization itself could be formulated in many ways. And I'm very much interested in sort of exploring these different ways of looking at the problem. The other thing is what Ahmed was asking, quantification, in fact, is different from explanation, right? So obviously, the very obvious one is to look at underlying data distributions. Then even your formulation can account for the underlying data distribution, right? And you can normalize by that and then come up with your own quantification according to the underlying data distribution. But there may be other hidden aspects, right? Given that we're talking about the, in this case at least, it's an opaque algorithm that's being evaluated. Okay? The other thing I didn't mention also is that we've also tested our approach with data that is, like semi-anonymized, right? So, for example, even K-anonymized. Right? And how far can you go, right, with a K-anonymized data set in quantifying, in doing your partitioning and quantifying your discrimination? And finally, there's a number of open questions. Okay? So one has to do with the notion of repairing discrimination, right? So people have worked on that at CWI, for instance. There is a number of proposals to how to revisit basically your classifier or revisit your ranking in such a way that you're addressing some targeted fairness, criterion. Okay, so the way we're looking at it is more as an interactive problem, right? So you give a certain ranking function, and then you talk to the system and look at different ways. You say, instead of really giving a function, there's actually a family of functions. I mean, the simplest form is you look at it as a weighted linear combination of a number of attributes that matter for qualification, and the system tells you what are the best weights. And best being, like how to be the least discriminatory possible with respect to a certain population. And currently we're actually formulating another problem, which is a comparison across multiple platforms, right? Which is basically, how do you use one platform to dictate a number of partitions, certain groups, and then you want to see what's going on in other platforms. I'm done.
Thank you. Very interesting talk. I have a question from a social science perspective. In order that we can actually target the right group finally to repair discrimination, we need to know the cause of the problem. And in all this kind of research, are you claiming causation or correlation? So how can we move beyond correlation in order that we can develop a framework that can establish causation? Because in AI, there's also a limitation. And second, do you actually do the interpretability based on empirical data so we can verify whether these are the real causes or not?
Yeah, very good questions. And answer the second one. I think the second one, there are a number of things we can do. We can obviously gather feedback, like run user studies and gather feedback, and then eventually, aggregate that feedback, for interpretability reasons. Yeah, and I think that's would be a great thing to do. The first one is a little harder. Yeah? It's harder because of many reasons. I mean, as I said earlier, obviously it could simply be an artifact of the data. Right? It could be an artifact of the algorithm, right? Or of the scoring function itself. What we're trying to do is really to break things down and isolate sort of the cause of the individual parts, right? Whether those are all reasons or, causes, but then they are potential causes. Are they causes? I'm not sure. I think the potential for finding actual causes comes from something that goes beyond a single platform, right? Because what you're trying to really mine, in a way, is the practices, right? What's in people's mind, whether explicitly or implicitly, but what are the latent reasons behind which these things are happening? And I think I'm very hopeful about sort of really looking across platforms. Absolutely. If it's the same pattern, if it's different patterns. So in a way, it's like statistical significance in an empirical way.
Okay, thank you.
So I have a question from a computer science perspective, more of a question. So in those partitions that you do, so the idea is that you try to find which partition has the highest unfairness.
Yes.
And in that sense, you detect that there is something wrong. But then, in order for this measure to work correctly, shouldn't these partitions have equal size?
They don't have to have equal size. So what I do is that I take those partitions, right? And I actually normalize them. right? By the scores within the partition itself, the min-max score, for instance, right? Because really, what's the intuition, right? The intuition is that as an individual, you may fall into any number of partitions, and your rank is going to be very different, right? And obviously because of the size, right? And because of the score distribution, right? And a lot of these problems come from tiny difference in scores. It's not even that you differ really so much from the top 100 that are at the top of you, right? So there is a normalization first in terms of the scores, the score values, right? But they don't have to have the same size, right? Because what I'm saying, I'm not talking about fairness in exposure. I'm simply talking about fairness in qualification.
So you expect the distributions of score within partition?
The distribution of scores normalized within each partition.
And so they're normalized in a way that the F1 resistance can be always measured among them?
Absolutely. Yeah, because what's happening is that I am actually bringing everything back into the same interval, overall interval. But actually, let's look at different ways of normalizing that. Other questions?
You wanted to ask? So, I just want
You
to
raise your hand, that's what I thought. Okay, thank you. I just want to ask that your question be kind of like considered as a way to identify some outliers in the group in terms of the distribution.
Yeah, rather than solving a sort of a maximization, find me the partitioning that maximizes the thing. I can also ask the question of, find me the partition among all possible partitionings where that partition may appear. Find me the partition whose score distribution is the farthest from everyone else. Eventually, I mean, I could see it that way, right? So each partition can be sort of put into a space of partitions, other partitions that it belongs to, and then I can also look at how far it is from the farthest partition. So it's a diameter problem per se, right, eventually. I don't know if it's an outlier, but at least I can find a partition that suffers the most or that, suffers the least from ranking.
Because I think it's very interesting to even just explore the definition of discrimination.
Absolutely, yeah.
Many ways to do
And it doesn't have to be organized in a tree, right? I mean, you can think of it as also using other kind of algorithms that, I don't know, maybe even sort of as a graph, but I don't know how would that work.
in terms of the complexity of the problem, that is not probably an issue. So, see,
Well, it becomes an issue, obviously the space is exponential in the nether attribute values, right? If you're thinking of, and it's very sparse. It's just like in mining. Okay? I mean,
So you do solve it optimally, so
we do not solve it optimally except in the case where it's small like TaskRabbit. We solve it, we have a heuristic. With the stopping condition that says keep partitioning by choosing the next attribute with the highest gain, and stop whenever you have seen a higher partitioning than the highest one is.
Any questions from the student? Yes, that's good.
You study the fairness from workers, but I think for requesters or for the platforms, they have a different definition of fairness. Do you consider that?
We don't, but that's a very good question. It's definitely the question of multi-stakeholder fairness, right? First, there is a feasibility question, and obviously, are they contradictory or and also, they're after very different things, right? Platforms are mainly about throughput.
Yes,
Right?
they consider the
You know
value.
that, right?
Yes, yes.
On throughput in crowdsourcing. But yeah, requesters is also very different, a much narrow-minded view. It's the most narrow-minded view, requesters, right? The platform is really about sort of, publicizing the fact that tasks are being, basically number of tasks per minute or things like that, right?
Yeah.
So I don't know how to do it for multiple stakeholders on the same platform. Yeah. Not yet.
Okay, thank you.
any more questions? Okay, let's thank the speaker.